All right, it's time for our last lecture and new information about temperatures. Same instructions, you're going to listen, you're going to take notes in your notebook, write down anything you think is important, key vocabulary terms and ideas. When you're done, you're going to get a notes check. Come see me. So, let's talk about our lab from yesterday. We were taking temperatures of different colored materials, and we get it that, dark things soak up sunlight and their temperature goes up, whereas lighter colored materials will actually reflect sunlight and their temperatures don't go up as much. What we want to look at today is, what about the green turf versus the green grass? We saw a very distinct difference even though they had approximately the same color. Let me show it to you this way. Here's the white square outside versus the black square. We get it. The dark stuff is going to soak up energy and become hotter. But grass, which is a very dark green, was really the coolest of them all. So something different is going on here with living grass. Even though it's a dark color, something different is happening which severely affects the temperatures, and you can see it right there. This whole presentation is about the effect of plants on temperatures, and they have a very significant impact on what the temperatures of an area or the globe is. First of all, photosynthesis. This is a term that you guys all know what it means. You know that photosynthesis is when plants take sunlight and they use the energy from sunlight to make food. That's what plants do. That's how they survive. But here's the trick. Sunlight, if it's being used to make food, it can't be used to raise the temperature of something. Think about it this way. Imagine you have a dollar bill and you got two choices with that dollar bill. You can either save it or you can spend it. You can't do the same. You can't do both with the same dollar bill. I mean, you could save half of it and spend half of it, but a single dollar bill, you have to make a choice. You either save it or you spend it. Sunlight's a lot the same way. Sunlight basically has two things. There's two things that are going to happen with sunlight. One, if it hits something and it gets soaked up by that something, the temperature is going to go up. It's going to get energy, the particles are going to move faster, more friction, higher temperature. You get that. But with plants can take that energy from the sun, and instead of getting hotter, they're going to take that sunlight and use it to make food. These are the only two choices that basically you can have with every ray of sunlight that hits an object. The temperature is either going to go up or the sunlight is going to be used to make food through photosynthesis. Consider a parking lot. Think about sunlight that hits a parking lot. Which one of those two choices is going to happen? Are you going to raise temperature or are you going to photosynthesize? Well, parking lots aren't plants. There's no chlorophyll. You cannot photosynthesize sunlight with a parking lot. Therefore, all of the sunlight that's going to hit a parking lot is going to be used to raise temperatures. And this is why parking lots get so hot. On the other hand, think about sunlight that hits a tree or sunlight that hits the grass. These are living things with chlorophyll in them, chloroplasts, and they want to photosynthesize. They want to take that sunlight and turn it into food, and plants are very good at doing so. So think about it like back to the dollar bill kind of argument here. If you give the dollar bill of sunlight to the parking lot, it's going to take it and use it all to raise temperature because that's its only choice. Plants, on the other hand, are going to take sunlight and use it for making food. That's what they want to do with sunlight. So on the flip side, plants will not get hot sitting out in the sunlight. And you know this. Hottest of all summer days, go out and touch a leaf or lay down on the grass. It feels somewhat cool. Plants just don't get hot because they are using the sunlight to photosynthesize. Therefore, the sunlight is not going to make the temperature of plants higher.
So here I am at the former Super Target on Holcomb Bridge Road. And you may not know this, but up until not too many years ago, this entire area was a forest. It was nothing but trees. Well, they came and they cut down all of the trees and they paved this parking lot and they built the building back there. So what does that have to do with temperatures? Well, on a nice sunny day like today, all of the sunlight hits the nice dark parking lot, hits the metal building, and all of that sunlight gets soaked up, which means the temperatures go pretty high. The temperature of this parking lot is about 120 degrees. Now, what would have been different had they left the forest here? Trees will soak up sunlight, but they use the sunlight for photosynthesis to make their food. Well, if the sun's energy is being used to make food or photosynthesize, that energy then cannot be used to make particles move faster, create more friction, and raise temperatures. So we know this, that plants help keep the temperatures cooler because the plants will use the sunlight for photosynthesis. This parking lot can't do that, so you build parking lots, you build buildings, and the temperatures go up. Roswell is now hotter than it was before they built this super target. So the more trees we cut down, and the more parking lots, and the more roads, and the more buildings we make, the hotter an area gets. That's a phenomenon known as the urban heat island, or the fact that cities are hotter than the countryside because we take away the plants and we replace them with materials that just get hot as they soak up the sunlight. So once again, this leads to the phenomena known as the urban heat island, or the fact that cities are hotter than the countryside because there are so many fewer plants to soak up the sunlight. All right, so now I've gone just a few miles away from that previous location, and I'm on the Big Creek Greenway, which is a large area of undeveloped land here that runs from Forsyth County all the way through Roswell and Alpharetta. And as you can see behind me, there is no development here. There is no roads. They've left the trees and all of the plants in place. And when you take the temperature reading here, the temperature here is about 83 degrees. And that's because all of the sunlight is hitting those trees, it's hitting these plants, and the plants take that sunlight and soak it up through their leaves, and they use that energy to make their food through the process of photosynthesis. Well, a road and a parking lot can't do that, so when sunlight hits roads and parking lots, the temperature goes up. But if we leave plants and trees in place, it dramatically lowers the temperature of an area because the sunlight is used to make food for the plants and the trees, and therefore it cannot be used to make particles move faster, increase friction, and raise temperatures.
Now, another way that plants actually help with controlling temperatures is this process called transpiration. You might not remember this from ninth grade biology. Basically, transpiration is plants that release water into the air. They pull water out of the ground in their roots, and they pull it up through their leaves, and they release water into the air. Now, we know what water does. Water helps to keep temperatures from getting too hot. So if we have a lot of water in the air, temperatures will not get as hot. They won't change as much. So the more plants you have around, the more transpiration or water you have going into the air, and hence the more stable your temperatures will stay. They won't get quite as hot. You can see this here as a thermal image of a city. Notice that the road over here is really super hot, but the grassy area appears to be really super cold, even though they're sitting under the same amount of sunlight. Now here's the problem. When we clear forest and we cut down all of the trees, all the sunlight that was hitting these trees over here was being used for photosynthesis, which means the temperatures weren't going up. Now sunlight hits this area over here. Now there's no more photosynthesis going on, and all that sunlight is therefore going to do the only other thing that the sunlight's going to do, and that is raise temperatures. So where are there less plants and trees? In the cities. You know, in cities, we cut down all of our plants and trees and we build buildings. And all of those buildings, when they get hit with sunlight, just get hotter. So therefore, cities are going to be hotter than the countryside because there's less plants and trees. If you look here in average October 18th high temperatures, city of Atlanta, 72, Roswell, 70. Now, it doesn't seem like a lot, but I mean, we're neighbors, and this is a historical average over many years that Atlanta seems to always be about 2 degrees hotter than what Roswell is. Well, take a look at the difference. Notice that in Atlanta, it's pretty much all buildings, a lot more roads, whereas here out in Roswell, we've got a lot more trees, and those trees help to keep temperatures from getting as hot because the trees soak up the sunlight and use it for photosynthesis. This is what's known as the urban heat island effect. And it's a very simple concept, and that is that the temperatures in the city tend to be higher than the countryside around them. This is a red bold-faced word. This is a definition that you need to write down and understand. Here's a thermal image of the city of Boston. You'll notice how hot it is. All these red hot temperatures over here in the city. You can see all those buildings. Yet out here, notice where we got a lot of blues because there are a lot of trees out there. Here's Paris, and you'll notice all the cool areas around here in the countryside, but right in the center of the city, it's exceptionally hot. You can see it. Here's a satellite image of Minneapolis, St. Paul after a snowfall. And you can see that in the city of Minneapolis, there isn't as much snow because it was hot enough, because it was a city, to actually melt the snow. All the countryside around here has snow cover because it's actually cooler outside of the cities than it is in the center. You can see this on any kind of daily weather report. You notice here's Atlanta, 65 degrees in Atlanta. And look at all of these other temperatures around Atlanta. Every last one of them is cooler than being in the city because of that urban heat island effect. Question is why? What's different about the suburbs versus the cities? Well, we're going to look at Atlanta and see how Atlanta has changed over the last 30 years. In these images, green represents a place where you have at least 50% of the ground is covered with trees, and red and black represents places where, roads, houses, buildings, sidewalks, things like that. Here's Atlanta in 1973. There's the downtown core. Starting to get out, this is kind of up 85, and this is kind of going up 75 towards Marietta. You can see there's a lot of green in Atlanta. Most of Atlanta was a city of trees in 1973. Now, by 2003, the city has exploded. Notice we've cut down so many more of our trees, and we built more malls and houses and roads and parking lots and shopping centers. So now there is significantly less tree cover in Atlanta in just that 30-year span. What difference does that make? Well, with fewer plants, the temperature of Atlanta is going to have changed because we know plants make a difference. So take a look at this temperature graphic. Here's Atlanta temperatures in 1973. Notice there's a little hot spot right there in the center of the town. A little hot spot down here by the airport where there was a lot more buildings and such. But the rest of the city was pretty much green. Well, now look at how much more hot zones we have here in the city because we have built so many more roads, parking lots, houses, buildings, shopping centers, and we have cut down so many more of our trees. Here's New York City. New York City, big, popular city, lots of millions of people live there, lots of buildings, but you'll notice right in the center of New York City, there appears to be a little cool spot. Now, I think you can tell this spot here and this spot, those are rivers, which of course the rivers, the water, they're not going to get as hot. But this spot right here in the center of New York, that's not a lake, that's not water. What's going on right there that makes that part of New York City so much cooler? That's Central Park. And you can see it. Look at all of those plants and trees that they have in Central Park. So this part of New York City right here is actually cooler than this part right here. You can actually feel it in the summertime. It's one of the reasons why in big urban cities, people will go and hang out in the park because it feels better. It feels a little bit cooler than all of those buildings which just soak up all the sunlight and get hot. So why should you care? Why am I telling you all this? Well, this has a direct impact on you because the hotter a city is, the more you have to run your air conditioner, which means the more you have to pay money for the electricity to run the air conditioner. The more people that are running their air conditioners, the more electricity needed, the more it costs everybody. So we should all care about this urban heat island because it is expensive. It costs us more money and we don't want to pay it. So what can we do? There are actually things that you can do to help reduce this urban heat island effect. First of all, we can plant as many trees as possible. Now in cities, this is kind of challenging because we've used all of our land. We've already built buildings and roads and houses and parking lots and so forth and so on. And we're not very apt to cut them down and replant trees. But there are some tricks that we can do. Think about a parking lot like this. We still have our parking lot, but yet we throw in some trees here and there, and that's enough to help mitigate the temperatures. Whereas if this whole parking lot was just all asphalt, it would get significantly hotter than with those sporadic planting of trees. Think about the difference between these two parking lots. This parking lot over here is going to be a lot hotter than this one here, because this one here you can see they've left some grass and they put in some trees, and this is actually something that is actively being done now in cities across our country because we recognize this urban heat island effect and the cost to us. So a lot of times now parking lots are designed to have a little bit of extra greenery in there to help mitigate the temperatures in the cities. You can also plant what's called, or make what's called, a green roof. A green roof is where you take the roof of a building, you put any kind of plant on the top of there, and those plants will soak up sunlight and keep from getting too hot. Whereas if this were a regular building, the building would just get hot and radiate heat and kind of glow infrared radiation and make the city hotter. But now, by putting these plants on the tops of buildings, the sunlight that hits this building is now going to be soaked up, and those plants are going to photosynthesize, and it's going to keep the city from getting a little bit extra hotter. This is also something that we're going to see more and more done now in cities across the country and actually across the world. This one's in Singapore. It helps keep the temperatures of cities lower. Here's another one. This is in Fukuoka, Japan. And this is a really extreme case because they've actually got trees on the side of the building. Trees, bigger, more surface area in terms of the total area of coverage, total area of green in their leaves. Trees actually soak up a lot more sunlight than something like a plot of grass would. So the more trees you can have, the better. And you can see the side of this building is just covered in trees, and all of the sunlight that hits this side of the building is going to be soaked up by those trees and used to photosynthesize, and therefore will keep the temperature of the city lower. This is important in a very crowded, dense country like Japan. Here's what the city of Fukuoka normally looks like. Most areas of it, they built on every square inch. You'll notice there's almost no green in this picture at all. So all of the sunlight that hits almost anywhere in this picture is just going to make things hotter. Here's an example one in Edinburgh, Scotland, an apartment complex. You see we've got some little grass up here, and we've got some trees planted on top of the building. This is in Berlin, Germany. It doesn't look very pretty, but it doesn't have to be pretty, because remember, this is on top of the building. Most people are not ever really going to see this. You can plant any kind of plant up there, anything that'll grow. It doesn't have to be, a perfectly manicured lawn. It doesn't have to be pretty flowering bushes. It can be anything green, any living plant that will soak up the sunlight that will help then keep the temperatures lower. This is in Hong Kong, and Hong Kong is another city kind of like New York, where it's really, really crowded, lots of buildings, lots of concrete. This is actually the old airport, where they had the runway, one big, huge, long strip of concrete, just soaked up sun all day and got hot. Well, they built a new airport out of town, and they built some buildings on here, and you'll notice they've got lots of green on there, because the rest of Hong Kong looks like this. It's all buildings, and you have very, very little place where you can actually plant any plants or trees to help keep the temperatures down. So in Hong Kong, they're very actively trying to find ways to put stuff on the tops of buildings to help mitigate the increase in temperatures, or to help lower or lessen that urban heat island effect. Here's a couple more examples. Once again, any type of grass or tree or anything you can put on top of a building that will help soak up some sunlight is going to help keep the temperatures lower. This one here, and it was in Iceland. This is in Vancouver, Canada. This one was in Auckland, New Zealand. So once again, this is not a Roswell, Georgia thing. This is not even a USA thing. This is a global initiative to help try to keep temperatures down. And this kind of goes back to that global warming. We're building lots more roads and concretes and buildings and parking lots that soak up energy. We're causing the planet to soak up a little bit more energy than it would have before. So if we can kind of do something to help mitigate the temperatures globally, like planting more plants and trees, this can maybe help stop or help control the global warming, which might be getting out of control. Now here's the difference between a green and a conventional roof. You'll notice that this roof over here is green roof. This roof here is traditional. Notice it's a pretty dark color because a lot of older buildings have what's called a black tar roof. It's a black, basically almost like an asphalt on the top, which dark colors soak up a lot of energy. You'll notice, look at the green roof, look at the tar roof, look at their differences in temperatures. There's a significant temperature difference between these two. You can basically put plants any place where you can. Some other countries, they're actually putting, instead of rocks in between their railways, now they're trying to plant some grass in there, and it makes a difference. Think about, most railways have crushed rock in there. Well, rock just soaks up the sunlight and gets hot. I don't know if any of you ever had the opportunity, but I remember as a kid, there was a railroad track near my house, and you'd be walking through the woods. You'd come to the railroad track, and you'd cross the railroad track, walking across the rocks, and you can actually feel the temperature difference about how much hotter the railroad area was because it was just solid rock, soaking up the sunlight, getting hotter. Throw some grass in there, and it's going to help keep temperatures down. Now, in addition to plants, if we use some different colors or different materials, we can help change the temperatures of cities. Now, this was an example being used to demonstrate how you can maybe use less electric lights and get the same amount of light. But if you paint things a lighter color, you know that light colors are going to reflect more sunlight. Now, notice this side over here, the light or the sunlight, if it were during the daytime, gets soaked up by the darker colors. Well, if you're soaking up the light, you're going to have a higher temperature. Over here, you'll notice how much brighter this is because when the light hits these lighter materials, it actually gets reflected. So there's a twofold advantage to doing this here. You can actually keep your temperatures cooler by soaking up less light. You also need less light bulbs because your area is going to appear brighter because the light is going to be reflected, which once again uses less electricity for the air conditioner, also uses less electricity for lighting up your area. If you go to a developing country or a third world country, one where air conditioning maybe isn't necessarily so prevalent and it's a hot location, you're going to see a lot of light colored buildings. This is in Dubai. Almost all of the buildings were white or light tan or pink because those light colors, when sunlight hits those light colors, it's going to bounce off. They don't want to soak up energy because they're in a very, very hot, sunny location. So they paint their buildings with white, lighter colors so they don't soak up energy and get hot. Just recently, this was just in the news last week, some scientists have created the world's whitest paint, and the thought is that it could help do away with some need for air conditioning. This paint reflects 98.1% of all the sunlight that hits it. So almost every bit of sunlight that hits that white paint gets bounced off. Well, if it doesn't soak up the sunlight, it's not going to get hotter. Well, that means it's going to keep the area cool. And actually, this paint actually acts as a cooling mechanism. It actually cools the area around it because it emits more energy than actually hits it. So it's stuff like this that we're going to be using to try to keep the temperatures of cities a little bit lower, lessen that urban heat island effect. Now, this is what's called a cool roof. Now, a cool roof isn't necessarily paint, but you can put a fabric, specifically a lighter colored fabric or building material on top of a roof, and now most of the sunlight that hits it is going to bounce off. The more sunlight bounces off, the cooler the building stays. And the guy that owns this building who has to run the air conditioner would probably really much like that because then he has a lower electric bill because his building's not getting as hot. A warm roof or a darker colored roof is only going to reflect about 20% of the sunlight. These cool roofs can reflect up to about 80%, or if they use that new white paint, possibly even up to about 98% of all the sunlight that hits it, which means you don't have to use a lot of electricity for the air conditioner to keep the temperatures cool. Here's a good example. This is in Chicago, a kind of old-timey building. See, they're all packed in there real tight. See a black tar roof and a cool roof. One's going to soak up sunlight, and it is going to get hotter. The sunlight that hits this cool roof is just going to bounce off. This guy over here is going to have to pay less for his air conditioning, and his house is going to stay cooler and more comfortable than this guy over here. Here's a good example of a cool roof. This is an office complex that had a cool roof installed. And you'll notice here's a black parking lot. Notice how hot the parking lot is, how much energy from the sun it is soaked up, and how hot it's gotten. The cool roof is exactly that. It's cool. So if we have more buildings with this stuff on top, our cities will stay lower in temperatures, especially in summertime. Asphalt parking lots, nice dark colors, soak up a lot of sunlight, get really hot. If you've ever walked across a dark parking lot in the summertime, you know this. You know they're exceptionally hot. This parking lot right here, a concrete one, will not soak up as much sunlight, will not get as hot. So that's another option. Or maybe paint the asphalt or paint the parking lots or the roads a little bit lighter color pavement so that it reflects the sunlight rather than soaks it up and gets hot. Dark pavement only reflects about 10% of the sunlight, which means 90% of the sun that hits it is going to make it get hot. That's why dark parking lots are so hot. If you have something what's called cool pavement, which is a mix of materials and a mix of colors, it can reflect up to about 40% of the sunlight. It's going to lower those temperatures. Here you can see a thermal image. Here is the cooler parking lot. There's the hotter. You can see this is up at the hotter end, and these colors here down at the lower end of the temperatures. This stuff works. It can help to keep temperatures lower. If we can, let's use less asphalt, because asphalt heats up very, very easily. It's a very, very dark color. If we can use more natural materials that have a different specific heat, it can help keep the temperatures lower. Use something like this. This is a kind of a new initiative where you have a big parking lot, maybe one that isn't used all the time. Instead of making it all asphalt, do something like this where you have grass in between the little pavers. All of that grass is going to soak up the sunlight and use it to photosynthesize, and it's going to help keep temperatures lower. When you go to places that are really, really hot, like Florida, there's a lot of sunlight, a lot of direct sunlight, you will tend to see buildings, especially your homes, painted lighter, brighter colors so that when sunlight hits it, it will bounce off. Now, we would never see houses like this painted these kind of crazy pastel colors here in Georgia because we don't have as direct sunlight. It doesn't get quite as concentrated even in the summertime here. So places where it's warm, they've been doing this for years and years and years to help reflect sunlight and keep the temperatures lower. Here's Aruba, which is near the equator. Almost all the houses, especially because a lot of them didn't have air conditioning traditionally, they'd be painted very, very light colors to help keep the temperatures of the cities down. Puerto Rico, see, once again, kind of light, brighter pastel colors. You wouldn't see this in Chicago or New York or Washington, D.C., London, places that aren't so hot or don't have really concentrated sunlight. Greece, almost all the buildings were painted a very, very bright white so that they can reflect most of the sunlight and not get so hot. So here's kind of a summary. Here's our new vocabulary that you should have had into your notebook. Only 4 new terms, and you knew what photosynthesis was already. Make sure you have these in your notes. Some key concepts. How do plants use energy from the sun? And next step, what does that do to temperatures? What can be done to lower that urban heat island? And there was just more than one thing. There were a couple of things there that you can do or can be done to lower that urban heat island effect. And finally, why should you give a flip? Why should we care about this urban heat island? And why should we try to keep cities a little bit cooler than they are with all of the man-made stuff? So that's the end of the presentation. Time to take the notes check.